reactive clearance. So if you missed that, I just told you the reactive clearance calculation. You remember the formula I put on the board, right? There will be a picture of the nephron. Remember the nephron? Remember the labeling of the nephron? I told you it'll be a little more advanced, like it may not be like in the intro where it's just gimmies. You may have to label stuff like the periticular capillaries, the vasa recta. Remember those little capillaries that surround it? Stuff like that. Don't look at your, like, when you learn the nephron, I want you to learn it as if, draw your own picture of a nephron, because I'm not going to just mimic the very exact picture that's in the book, so don't just memorize where the stuff's at. It's a picture of a nephron. I'll have it where you have to label it in a certain way, okay? You don't have to draw the nephron, but you'll have to identify parts of it.
Yes, sir.
There are some level 3 questions on the last page. A lot of times I take those from case studies that's in the back of the chapter, okay? So I'll always tell you, even though we don't go over them, read those case studies. You'll answer case studies at the back of the chapter.
This is 1 through 4.
Chapters 1 through 4.
Okay.
All right. Talked a lot about safety. I don't think I need to be real specific on safety. Make sure that you study that chain of infection. Remember, I kind of whittled that down to 3 for you instead of like 9 things. Tell me some parts of the chain of infection, 3 primary things.
Order on entry. Mode of transmission.
You got a source, right? Like we're lab techs, so we're not doing it as standard precautions, but as the chain of infections, if you're a lab tech, what do you think the biggest source you have working in the lab, something that can make you sick is? The specimen. I want you to think of the specimen as the source, and then we've got to have a way that gets transmitted to us, right? So what did I tell you guys the main way you can get sick in the lab? Touch it. Touch it. That's the transmission. You touch the source. You touch a specimen without wearing gloves, right? And then you're the host, right? And then the host, as the host, now you become the source, because now another employee can get sick because you're sick, okay? So remember the chain of infection. There's 3 primary things that I wanted you to know.
Source, transmission, air.
The host. If you're working in the urinalysis laboratory and you get a styrofoam box sent to you from an outside agency, what is that called? Proficiency testing, right? That's where you're doing testing from an outside source to make sure that you're getting the right results you're supposed to get, okay? That's not quality control. That has to do with basically you're being tested, all right, from your accreditation agency. What did I tell you a name for those surveys were? Those surveys that are sent to labs where they send you a styrofoam box that has
Proficiency survey.
CAP surveys. CAP surveys.
CAP.
And there's other accreditation agencies that send them.
API.
But CAP and API are probably your main ones. We talked a lot about what's considered the criteria for specimen rejection and things like that. What was the main thing that I told you about you have to watch out for your specimens?
People leaving it?
Or unlabeled.
Okay, but I mean like that just affects everything.
Like people leaving it in the little area for too long?
Yeah.
Like, are they held on to it for
Sit
too
at room
long?
temperature, your book is going to tell you for more than 2 hours. If you let a urine sit for more than 2 hours at room temperature, remember that chart that was in your book? It showed all the results that get affected by bacteria multiplying. Remember what bacteria do? Bacteria causes the color to change. Remember I told you the bacteria will actually feed on the glucose. So there's a chart in your book that talks all about that. Know about acid and water, about what gets added to what. Remember that should be in your safety section.
Acid into water, not water into acid.
information concerning health hazards, flammability, reactivity of chemicals, all of that information can be found in what?
Safety data.
Safety data sheets, what else, Darren?
That diamond shaped thing.
Yep.
NFPA.
Remember race, remember pass, remember the proper way to wash your hands. I've got a multiple choice question on the test about hand washing, about the proper way. What's the one thing that I told you guys when we were talking about hand washing? I told you to remember that some people forget.
Turn it off with a paper towel.
Right. Everything else is kind of common sense, but a lot of people may not know that to turn the faucet off with a paper towel.
Right.
How many nephrons are in each kidney?
1 to 1.5 million.
A lot, right?
1 to 1.5 million.
When we talked about reabsorption in the nephron, I told you guys that a lot of stuff is actively reabsorbed. Remember where it's got to combine with a carrier protein? But there's one substance that I told you that basically is passively reabsorbed in pretty much all parts of the nephron except for the ascending loop of Henle. But you got it? Water. Water is generally passively reabsorbed in all areas of the nephron except the ascending loop. Okay, if I asked you where the maximum amount of reabsorption takes place in the nephron, what would you tell me? Where most of the stuff is reabsorbed. Remember that picture I drew on the board? Remember I drew all those glucose molecules and I was showing you how they get reabsorbed? Where was I at on the nephron? That proximal convoluted tubule. That's where the majority of stuff gets reabsorbed in the nephron, is at the proximal convoluted tubule. So where did I tell you water is not passively reabsorbed?
The loop of Henle.
If we're measuring the filtration rate of the nephron, I told you guys one test to remember. Creatinine clearance. Remember, creatinine clearance is what measures the glomerular filtration rate, the creatinine clearance. Now, there are other tests that will measure that, but the main reason they use creatinine is an endogenous product that your body produces from muscle breakdown, okay? So they don't have to inject you with something or send you into the outpatient. They can actually send you home with an amber jug and tell you to collect the urine over 24 hours. What is the most common reason for results to be crazy on a creatinine clearance? Remember I told you guys something about 24-hour urines that
No, they didn't void the first one.
they're improperly collected. Most of the time, guys, if you're working in the laboratory, you're not going to have any control of this, but those patients have to be given specific instructions. Because, you know, if I didn't know any better, like if I had never worked in the lab or anything, and they gave me a jug and said, I want you to collect your urine over a 24-hour period, I would think that whenever I started, I would empty my bladder into that jug, right? That's not the way you do it. If you start at 8 o'clock, at 8 o'clock in the morning, you're supposed to empty your bladder into the restroom, right? Then you start collecting, and then 8 o'clock the next morning, you empty your bladder into the jug. Even if you don't have to go, you try to go, right?
Mm-hmm.
That's the way that you collect it. Now, I'm not going to ask you a question on how to collect it, but I do want you to know that the collection process is the most common error that's made in a creatinine clearance. And remember, there will be a creatinine clearance calculation that you have to do on the exam. Remember that antidiuretic hormone that we talked about? I talked about vasopressin. What tells your body whether or not to produce that?
Dehydration levels?
The hydration status. It's that simple, okay? If you're dehydrated or not, that tells you whether your body needs to produce anti-diuretic hormone. That is produced to help your body conserve what little water there is. So if you've been mowing outside all day and you hadn't been drinking liquids, your body, if it works right, is going to produce that anti-diuretic hormone. Anti-diuretic means it's not going to let you pee up or void off a lot of urine, okay? So if you don't void off a lot of urine, that means that your body's conserving it and it's reabsorbing any water, getting it back into the blood supply. You don't need to void off water if you're dehydrated. That makes sense to everybody?
Mm-hmm.
You gotta conserve that water.
We're gonna figure that affects your ADH right now.
Yeah, but remember that condition we talked about called diabetes insipidus? That's where your ADH doesn't turn on.
Yeah.
Okay? Remember how I told you how you can tell the difference between someone that has diabetes mellitus and diabetes insipidus? All of the symptoms are the same. Remember, both patients, if you take somebody that has diabetes mellitus and diabetes insipidus, both patients will be thirsty all the time. What's another name for being thirsty? I think polydipsia or something.
Yeah.
Okay? They're both gonna void off a lot of urine. But a person that has diabetes mellitus, their urine, the specific gravity is gonna be a little more concentrated because they have all that glucose in their urine. A person that has diabetes insipidus, it has nothing to do with their glucose level. It just has to do with they're not producing anti-diuretic hormone, so they're voiding off large amounts of water. The body's not, it doesn't have that little governor on it saying, hey, conserve water. So if they void off urine all the time, they're gonna be thirsty all the time.
They're gonna have clear pretty looking.
There was a picture that I showed you guys to know in your book about the buffering capacity of the body. Remember, bicarbonate ions are responsible for buffering the blood. But remember I told you, all the bicarbonate gets filtered through the glomerulus. And there was a process where a hydrogen ion had to be secreted to combine with bicarbonate to become carbonic acid, remember? And that way it goes through a little phase there, and your bicarbonate basically goes back into the blood, and it does not become urine. Make sure that you look at that chart over the buffering capacity. All right, it has to do with buffering and bicarbonate. The recommended specimen for routine urinalysis screening is what?
First one,
First morning specimen. Why?
because it's the most concentrated.
Good. Give me one urine specimen that you do not think could be used for a culture, a urine culture. Remember all the specimens? You got first morning specimens, you got catheterized specimens, suprapubic aspiration. What is one urine
It's
specimen?
not random because it's not plain catch.
Okay, random would work, but there's another one that you definitely would never want to use for a urine culture. A timed specimen, one that's
Yeah.
being collected in those 24-hour urine jugs.
Oh, yeah, it's been, yeah.
Yeah, because it's been sitting out.
Yeah.
I mean, hopefully they're refrigerating it, but you don't want to use one of those. What's the most common way to preserve a urine specimen?
Refrigeration.
Refrigeration. And why is that in most people's eyes the best way?
It slows down the bacteria.
Exactly. They don't have to add a certain kind of chemical. Because anytime you add a chemical, even though they do, there's an actual urine culture tube that a lot of times they'll send down it's got a gray top on it, but it contains two different preservatives in it. And those preservatives, they can sometimes get in the way of stuff they're doing back in microbiology.
I was talking about that. It's that one that we're trying to replace the gold in the green. It's just sort of like a gold. The fact that it clots faster than a gold.
Yeah, and it does, because this tube contains thrombin. You guys remember thrombin?
Mm-hmm.
See, I looked on it, because I heard orange top tubes. What it is, this has a clot activator. And so this actually, when you put blood in this tube, it's got a chemical that speeds up the clotting process. You ever heard of somebody that's going into surgery and sometimes they'll sprinkle a little bit of thrombin on the cut site? That keeps them from bleeding. Thrombin is like a clot activator.
Right.
Anyway, I ain't gonna talk more about that because we got enough stuff going on.
Oh, no, you're
But
fine.
Thanks for the tube.
You're welcome. I just thought about it when you were talking about that other stuff. I'm very dog.
Two things that can turn urine black.
Malignant melanoma and
Alkaptonuria.
Yeah,
For
that
gals, don't just remember alkaptonuria. There's a substance that causes that called homogentisic acid. That's what's causing the black. The alkaptonuria is the disease state, but the homogentisic acid is what's causing it to turn black. All right, so remember that word too. A urine that has a lot of white foam when you shake it. Protein. Yellow foam.
Bilirubin.
Good. We already know what's responsible for the urine turning yellow. Urochrome. What happens if you leave a specimen in the refrigerator too long?
Pink stuff.
no, it gets cloudy. Yeah.
Amorphous. Now, there's two types of amorphous. I'm not requiring you to know the difference right now, but there's one called amorphous urates. That's in acidic urine, and one called amorphous phosphates. That's in kind of an alkaline urine. But both of them is this precipitate that forms from refrigeration. Remember that dilution that I told you about? If you're doing a dilution on a specific gravity, how you calculate that? I'm seeing a few definitions, like you need to know the definition for specific gravity, refractive index. A urine with the same specific gravity as the ultrafiltrate is called isothenuria. Remember to be able to distinguish a red and cloudy urine, which we're going to reinforce when we go into lab today, with a red and clear urine. If a urine is red and clear, there's two disease states that go with that: hemoglobinuria and myoglobinuria. Okay, that's red and clear. If the urine is red and cloudy, hematuria. The definition for hematuria is there are intact red blood cells. Now, you will know that. If you're a tech working in the lab, you will know if there's intact red blood cells, because guess what's going to happen when you spin that urine down? There's going to be a big red button at the bottom, okay? And you're going to know right away, like, if I don't see red blood cells in this specimen, something's wrong, okay? If it's hemoglobinuria or myoglobinuria, a lot of times when you centrifuge the specimen, it'll still have that red color to it, but you won't see that red cell button, okay? Make sure that you know those terms: anuria, oliguria, nocturia, polyuria. There were about 5 key terms that I went over in one lecture. Let's go over those real quick. I hope I can remember. Nocturia.
Nighttime urination.
Okay. Give me a couple things that might cause that.
Diabetes insipidus.
Okay, something else.
Excessive drink. I mean, like,
Drank too much before you went to bed.
Good. Drinking lots of coffee at night and stuff like that. I mean, there's common reasons that can make you void a lot of urine or cause you to wake up in the middle of the night. What's the worst one out of all of them that you could have?
Polyuria.
No, polyuria can be from just you drinking lots of water all day. Anuria, what's that mean, Tanner?
No eating at all.
Right. Okay, you can only do that for so long or you're gonna die, right?
yes.
What do you think? I mean, just so we know, I don't think this is on the test, but what do you think happens to your body if you can't void urine?
Toxic.
Bingo. Everything's gonna become toxic. Even water can become toxic, okay,
Right.
if you don't excrete it. I mean, everything that's in your body, pretty much, if it just keeps accumulating and keeps accumulating, it can become toxic, okay? Especially if you're taking a bunch of medication, which unfortunately people that are in kidney failure are probably taking. So if your kidneys shut down and you're not voiding urine, now that stuff's gonna become toxic, and it's gonna keep building up. You have to excrete that stuff. That's why you void urine, all right? Is you're getting rid of things in your body that needs to be recycled, basically.
That's what Chris does, he doesn't do the blood, he does the, everything inwards, the waste product, that's what he cycles off every night.
There is a question on here about daily urine volume. So you had some volumes that it said, like I think
1,200 to
1,500 is polyuria. So you need to be able to recognize what a urine output is. If you're given a multiple choice test, like, would this be oliguria, would this be anuria, would this be polyuria, if they give you the number.
22.
The primary chemical constituents of urine are water. What's the two next biggest things?
Urea, sodium, and
Urea and chloride. Why is there not proteins in your urine?
Cause they're too big, they're too big to filter through your nephron, glomerulus.
Well, they're actually not filtered out. They don't go through the filter. Remember the
Right, they're too
glomerulus
big.
is a sponge, right?
right.
Remember the blood is received via the afferent arterio? Only the smaller things get filtered. So proteins for the most part are large enough that they exceed that exclusion limit, okay? So proteins don't get filtered for the most part, neither do white blood cells and red blood cells. So you shouldn't see that stuff in your urine. Now sometimes you can see that stuff in your urine because it's brought into your urine after the kidney, okay? But if it's brought into your urine before the kidney, that indicates kidney problems.
Okay.
If we have an unknown specimen that we see sitting on a table and we don't know whether it's urine or possibly amniotic fluid, let's just say they broke every rule in the book. They didn't label it, they didn't put anybody's name on it, and the lab director says, hey, I need to know what that is, okay? What could we test it for to find out? Urea and creatinine. That's close what you said. Creatine and creatinine. I think creatine is what those bodybuilders take, right?
Yeah.
That's kind of like creatinine, but creatinine is actually the waste product that your muscles, when they break down and build up, they produce. I think there's a powder called creatine. You can get it from the GNC Center. All right, guys, I think I've told you a lot. Study. Do good on the first one, get off to a good start.
Yes, sir.